We are live. So if I go view and present. All right, everyone. Welcome to tonight's Omaha Data Science Academy lecture in the class Data Manipulation and Management. This is about storing and managing data. So storing and managing data in the context of a business enterprise, like how do they go about storing and maintaining and managing data? Just the storage part's a pretty big effort in itself. So extracting data from various systems, being able to store it in relational databases so it's useful, is just one effort in its own. But the managing data part, it's just as big as that, and it's ongoing also. So Michael, if you think about IT systems, the storing is almost like the building of the system, extracting it and storing it. Or I think of it this way: is extracting and storing it. You're kind of building that storage data or that footprint, and then the managing data is like all of the maintenance that goes into the system. So a lot of people think like data is like this static thing that's always true, but it's often contextual. It is only a fact in its certain context, or maybe it has different context. Maybe, like it's in the product context of various products. Maybe it's in a context of different companies or different clients or different vendors or whatever. So there's a number of things that you have to do to just manage the data. So these are things like creating business rules, documenting those business rules through data dictionaries, creating KPIs, so creating those KPIs that are those key performance indicators that are meaningful to the business, and data quality and data stewardship. So making sure the data remains the highest quality. Maybe it is when you start, but the data gets old and out of date, or you need to start storing it in a different way. So making sure it remains the highest quality, and then stewardship. So making sure it continues to have the right context. So within an organization, there can literally, you could have a massive team of people doing both the storage and managing data parts. And in big enterprises, you often see pretty sizable teams. So I worked years ago at First National in 2008 or 2009, even before these BI systems were, becoming widely popular in business. They were at the time, but banking tends to be more data driven than most industries. But even at that time, we centralized IT with the people who did business intelligence. And we had a team of 50 people just working downtown at the tower, working in bank credit card. And that was just one division. That was just one division of First National Bank. And you have people working across other divisions and trying to collaborate and consolidate data and everything. So this can literally be like just a massive enterprise across an organization to be able to do this. And I think it's also good to cover this lecture too, because this provides context to now SQL and relational databases and all the things that you can do with it. You can design a database. You can store and manage and clean data. Now just seeing it in the context of an organization. So now what maybe you'll possibly encounter if you're to go to one of these organizations that's data driven or has BI initiatives or whatever. So what you can expect and maybe where some of your experience may also apply. All right, so on with the lecture. All right, so the review of the last class. So we actually did cleaning data last class, didn't we? Instead of the design. Is that right? Oh no, we did. We did storing and managing data. So that was, well, no, I'm going crazy. We did do the data. We did OLAP and OLTP, right? Okay, so I'm going crazy. I got the lectures mixed up from last week, but this is what we did. So after we applied our SQL skills in class 5 to be able to clean data and store data and get it in the way you need. We did class 6. So we talked about the purpose of database modeling. So structuring those tables in a way that either best captures transactions like OLTP database, or captures and stores data for analytical purposes. So two different purposes. You're using relational databases in both, but the designs can be a little bit different if you're doing it to do this efficiently, be able to store data efficiently, whether it's to capture transactions or store it for analysis purposes. And all those other things like the accuracy, validity, uniformity, and so forth. The proper design helps with all of those. Entity relationship diagrams are related to OLTP systems. So this is to understand the entities and the relationships. So kind of like those system nouns like we saw with the repair shop example. So you have customers, you have invoices, you have subjects. So the subject, repair subjects. So like cars and houses and vehicles and stuff like that. And then you have the relationships between them. So like a vendor inside of the system can have multiple accounts. And then defining those relationships like one-to-one, one-to-many, many-to-many relationships, mandatory one-to-many, so forth. Relational database modeling goes along with that, creating the physical models for the database. So once you gather all of your requirements, whether it's OLAP and OLTP. So OLAP you might decide on a star schema is most appropriate with facts and dimensional tables. Then you need to physically design the tables themselves and the relationships. That's what we covered in that section. Normal forms mostly apply to OLTP, but you see overlap with OLAP. The normal forms you have, first normal form is just how far it's kind of like the baseline for perhaps what you should have for the vast majority of tables within your database. Second normal form and third normal forms are improvements on those. But even at that, with the OLAP, you see some of these concepts, and it's just slightly, you'll normalize these first, like an OLTP database, but you'll kind of denormalize these slightly for your analytical purposes. So not a whole lot, but you want to take some of this data that you're capturing transactionally and just manipulate that in a way that maybe not all your rules are there for second normal form, but it makes sense from an analytical point of view. And then just the last dive on OLAP and dimensional data modeling. So how do you structure that database for analytical purposes? It's saying you usually will have fact tables, and then you have a number of peripheral dimensional tables. Those dimensional tables are often business rules or some type of business segmentation. So a business rule would be, is a client active or not? True, and then maybe it's a true or false field. And maybe a business segment is customers. So you list all of your customers in a dimension. You list all of them in a dimension, and then you can join that to a fact table like your invoices or your transactions table to be able to get all the transactions by each customer and break it down that way. And then maybe for those customers, you have what locations they're in. So you could possibly plot that across the United States. So that's the idea of how you design that database. You join dimensions to facts to make the facts, give the facts context, and bring them to life and answer business questions. So before I get too far, I also want to run the banner here for the class. It's not class 6, it is class 7, storing and managing data. Do that. So if we refer back to this, we can easily see what class. There we go. All right. All right. So the class 7 objective. So the ticker I launched down there is storing and managing data within the context of the enterprise. So we're going to, just like any good technological discussion, we're talking about data or anything technical in the enterprise. It's good to get the terminology first. So understanding the lingo, what gets thrown around here, some of the acronyms, and be able to familiarize yourself with not just the terms, but also some concepts like ETL, and then operational data store. So how you store data to be able to use for analytical purposes and so forth. So the next part will be data management versus database administration. So two different things. I like sometimes I get a little bit confused in the organization. The role of a DBA is to kind of manage a database system more itself, and data management is the data within the databases and the tables. I want to discuss a little bit about how those roles are different. Data governance and measuring data quality. So in almost any business of large scale or size is going to have some type of data governance or data quality team. That's just continuing to make sure that the data is the highest quality, the integrity remains. Data governance is to kind of maintain it, make sure it's up to date, it doesn't go stale, it has context and meaning, and then just doesn't become irrelevant. So you have to continue to, as the business changes, continue to be able to update and maintain business rules and everything like that. So we'll talk about a little bit more about how data governance works within an organization. But likely something, if you become a data analyst or do analytics within a larger organization, you are going to come across those two things. Then data dictionaries to be able to fully document, kind of related to data governance and data quality, but data dictionaries become really important in organizations where you have multiple systems and you have data coming just literally flowing from hundreds of systems. And maybe you have similar data coming from one or other, but the context is different. The source of it's different. How it gets transformed is different. Data dictionaries are really a document that will help you kind of capture that and the business rules around it. So all the way from the source that the data comes from, like that original system or file, all the way to its endpoint where it's loaded. So potentially in a data warehouse or another, possibly even another system. But we'll take a look at data dictionary as part of the class project in this one. All right. Let's move on to the rest of the lecture. All right. Types of enterprise data. So all business enterprises have 3 varieties of physical data within their numerous information systems. These varieties of data are characterized by their data types and their purpose within the organization. So we've really covered OLTP and OLAP quite a bit, but OLTP is about the business events, being its systems that capture that. So things like ERP systems, CRM systems, customer relationship management, even like interactions between people. In some ways, like your accounting ledgers will be this way. So your accounting software and ledgers capture certain events. like entering new journal entries, or I guess you wouldn't delete journal entries, but any other things that you're doing within the system. QuickBooks you could even consider to be a transactional system in some ways. Then your analytical data, like we saw before. So taking a look at this picture, it's all about all this enterprise data and the data types, the transactional data and the analytical data. Analytical data is really about supporting decisions and measuring business performance and so forth. So oftentimes taking data from this transactional data set and transforming it here for analytical purposes to be able to answer those questions or measure performance. And we're also putting some new terminology into this. So master data represents the key business entities upon which the transactions are executed and dimensions around which analysis is conducted. So it describes the key business entities. So in a lot of words, think about master data. It's really like the glue that ties all of the enterprise data together. So it holds key business entities like customers, locations, product types, basically anything you use in an enterprise. And master data is like, how do you tie these in between the systems? Like oftentimes it's a lookup table or some type of store of information, even with how transactions are processed and executed in systems. So for an example, think about various systems. Maybe you have clients in both, like your front end sales system, like your web portal where customers are going and buying things, and maybe you have them in the CRM system. I mean, maybe these customers are named, like they have lots of variances in their names, like small variances, or they're just described differently even, or they have different fields. Like one will have like a customer type in one and customer type in the other, and maybe they're two completely different things. But the discipline, so it's about master data management is really like both a discipline of how to organize and bring and tie all that data together, and then physically like doing it, making that connection between transactional data and analytical data sources, and maybe even two different analytical data sources. You have two different data marts that you're managing with some different business rules. Then master data is talking about how do you tie those analytical systems or data marts together. So master data is becoming like a real discipline and management within the business. Even at Paradigm, we do quite a bit of master data management. So Michael, if you think of things like mapping billing codes, I know that you're quite familiar with those, or procedure codes to like different payers, different insurance companies, and then making sure all those tie together across different systems. It's starting to become a real management task. Like we have a small team and we're trying to we've had to re-engineer it even a little bit to think about what's the best way to just be able to manage that. Now, like we're acquiring different companies. They have similar dental management systems, but they're slightly different in their own ways too. And then the more differences the more master data is needed, and just more management of data there is needed to be able to tie everything together, make a common thread between all of it. So in our current situation, that's actually a pretty good example of master data management that we're putting in place. And if you don't have that in place, you're always doing analytics or reporting in different contexts. So you could report one thing out of one system and one out of another. thinking it's something really similar, but maybe the process that generates transactions or the business rules are just different in one or the other, and they're just apples and oranges for whatever reason. This is kind of like the attempt to consolidate that, and it's a consistent effort, really, as going forward. Like as the business changes or business rules change, this has to be updated, be able to continue to maintain that. So one part that I say is always very underrated from people within business is the amount of effort that just goes into extracting the data, transforming it the correct way, and then maintain it going forward. So very similar to IT systems as part of like design and creating, and then the maintenance and maybe the eventual end of life. But data is something more that perpetuates itself and it keeps growing, especially as you ask more questions. So it's just a continual management task going forward. All right. So data storage terminology, this is where we get into all of the acronyms. So one thing I'd just like to highlight here is that the data in this generally flows from left to right within the organization. Now, this doesn't include anything like a data lake that you could potentially have here where you toss a bunch of data in and then you figure out your transformations later. But just from a standard, extracting from online transactional processing systems to being able to transform it for analytical purposes and then transforming it once again for the end user's purpose. It's just a general workflow of at least how traditional online analytical processing systems come about, especially from relational databases. So we talked about OLTP quite a bit. So going from left to right, these are usually on a day-to-day basis where your data usually lives. This is probably where the majority of your data is coming from within the organization, if you think from just a pure volume standpoint. So think of a big business, even think of Paradigm with the number of oral surgery procedures or number of implants they do on a given day across a whole bunch of different locations, even different systems, bringing together, like a dental management system along with accounting and so forth. And it's not even Paradigm's not even that complex yet, but a huge organization may have all these data sources right here and even more that I haven't even listed here. It's probably where the vast majority of it's being produced. Sometimes for analytical purposes, you'll pull in stuff like demographic data. You can even pull in unstructured data nowadays, which doesn't fit as well into this model either. But semi-structured, maybe you're pulling in some text data. Maybe you're pulling in somebody's spreadsheets for analysis. That'll be some of the data. It'll often come from a spreadsheet, and then you'll do some extraction out of that spreadsheet or a CSV file and put it in your operational data store. I would say this is probably 90 to 95% of where your data is coming from, and then you have 5 to 10% other data sources. Maybe it's not non-system data sources, like things people are actually generating themselves or outside data or something like that. I started to talk about operational data store. So the operational data store, you can think of this as like a landing spot for multiple transaction processing systems and sources. It's usually cleaned and normalized data. So we're thinking of this in terms of a relational database. So you're extracting from all these data sources. You're using extract, transform, and load. So ETL is where you are either writing a script or using some type of tool to be able to extract out of these systems, transform the data the way you need, and load it into a relational database or the operational data store. Then from there, this data is often normalized to be able to prepare it for data warehouse purpose. And then you could see master data management is something that ties all of this together. So the operational data from your transactional systems, your data warehouses, and your data mart. Being able to tie all the data from these different systems together. So giving you another definition of master data management, this defines and manages the critical data of an organization to provide a single point of reference within the business. So that's what it's trying to do, is it's trying to centralize all of this, gather all the business rules and how you tie all of these together to give that like holistic perspective on the data, which can be a huge effort in its own right. So we talked about in the last slide. So going from left to right, so we have the normalized tables here. You take those normalized tables, and the data warehouse is almost always some type of dimensional model, whether that's a star schema, snowflake schema, and usually it's multiple schemas in here. So multiple fact tables. You could have facts about, vendor facts. So how much is being purchased from you. You have inventory facts. So what quantities and amounts do you have in your inventory? And then you could have, say, customer information, your customer facts or your invoices. So what type of facts can you get from your invoices? Like, what different products did they order? What dates did they order? What are the quantities? Where did they ship to and from, and so forth? So it's taking this data and designing it in a way to start to answer business questions. And oftentimes this data warehouse is split into different smaller data marts. So these are kind of like, think of these as each of like a small snapshot of the data warehouse. So maybe this is for marketing, maybe this is for the sales team, maybe this is a cut of the data warehouse for your inventory management teams or your buyers or your purchasers or whoever. So they get each a part of this, and then it's fed into BI tools, dashboards, and reports. And a BI tool could be Tableau, could be Power BI. Reports are often, maybe it's an Excel report or just a flat file going to your end user. So really like it's almost a whole life cycle here. So you get your data from your source systems, you're transforming it and managing it here, often all behind the scenes, transforming it in a meaningful way to present to the business, and then giving them access to it. So maybe this is some information portal. Hey, it's Power BI Cloud. That's what we use at Paradigm, or Tableau server, something that they're able to access and be able to see exactly what they need to operate their part of the business or answer those questions. Any questions so far? I feel like I'm covering a lot here as far as organizational data is concerned.
Tableau would go over into that analytic column, right?
Yep. So you could think of these data marts. They could almost be Tableau extracts, the little hyper extracts that you create in Tableau. So say you're querying the data warehouse and you create a Tableau extract. It's almost like a little mini data mart in a sense. And then that data is fed into Power BI. You create your visualization inside of here, or any number of BI tools. Maybe it's a reporting tool. Maybe you're doing advanced analytics or machine learning, right? And applying that in some way. And then having the user access them. So one thing I didn't put in here is now there's some BI tools where you can actually put this type of thing, machine learning models, straight into another application. So like if you're using, say you're using SharePoint or something similar on a day-to-day basis, you can actually create an application like a machine learning model and put it out on SharePoint and somebody be able to interact with it, which I guess is kind of like this, but you could actually do this into other applications too. So this could be Tableau. This would be some type of reporting platform that sends out everybody's daily reports. Maybe I go in information delivery, the part that I was talking about. All right, I expanded there quite a bit on yours, but I wanted to differentiate these and what I was talking about there. But yeah, Tableau and Power BI would go into BI tools. Not often are you creating your own tool, but you could, in data science, it happens sometimes. Good, Ronnie? All right. So just understanding the flow of data, you could see knowing how to use relational databases or just being able to work with data. There are any number of roles for you within an organization. As data grows and big data continues to get even bigger, I think there's more opportunity for people in this field. I think it's a good field to be in. All right, so what is ETL? So I've tossed that around a couple of times. ETL is short for extract, transform, and load. These are functions that will let you take data from different formats, manipulate the data in staging area, and then write to a target database. So in this last slide, if you think of ETL as far as extracting in your staging area and transforming it, this follows almost exactly this model right here. So you're extracting it possibly from different data sources, but often from transactional systems. Say your staging area would be the operational data store. Then you transform it one more time into the data warehouse. So your OLAP, your online analytical processing in your data model. And then you're cutting off slices of the data model to be able to present in Power BI or Power BI or Tableau, any number of BI tools or reporting tools, or even for advanced analytics purposes. So to break down each one of these steps a little more, the extract stage lets you take data from different sources and allows you to pull it into the centralized staging area. So interestingly enough, we're talking about it in this one in the context of your operational data store. But one thing that's becoming very popular instead of an operational data store is a data lake. So we actually have a data lake at Paradigm that acts like this, where we take a whole bunch of data and we do this extraction piece from wherever it's coming from, but we're just landing a bunch of different types of files in this before we transform and load. So we're just saying, hey, grab us all the data we can, put it in this area, and then we'll figure out what to do with it later. And it's really flexible because sometimes you're extracting data and you might not know all the questions that are going to be asked. So having a data lake there is often very valuable. Being able to do this with an operational data store is also valuable too. But sometimes that requires you to know more in advance what questions are going to be asked of the data. And it can always be updated too. But the new flexibility of the data lake is a lot of people are somewhat moving to that because of what I mentioned before, is that oftentimes you don't really know what questions are going to be asked of the data until they're asked. Or sometimes you load new data and it brings up a series of new questions that you could either never have anticipated, or maybe now you have to go get another data source or store more data to be able to answer that question. So either operational data store or data lake is what is commonly being used here for the extract and staging area. So now the transform stage lets you manipulate the data with certain rules applied on the extracted data. The goal is to load this data into the end target database in a cleansed, uniform format. So really this is starting to put together all the different pieces of our class. So the transform stage, you can really use SQL to do these type of things, to be able to query the data that's in the staging area, be able to extract it, manipulate it, store it, clean it up. All the things that we learned in those first 5 lectures is what goes on in the transformation stage. So even whether you're using an operational data store or you're using a data lake, even Microsoft Azure allows you to write SQL queries in a way into the data lake. So SQL is a really powerful tool for this transformation stage. And then at the end of this also, we'll see where you can use Python to do these transformations also. So not necessarily just using SQL, but potentially creating a Python or a pipeline, data pipeline that does a transformation, extract, transformation, and load in Python. All right. And then the load stage is the process of writing the data to the final target database. So that'd be the enterprise data warehouse. Oftentimes, it actually could be another intermediate stage, but oftentimes it'll be to the data warehouse after you've transformed it and loaded it. And this final target can be an operational data store, data mart, or data warehouse. So what I was saying is that oftentimes there'll be a data warehouse, but it doesn't necessarily have to be. There could be another intermediate step for whatever purpose. Maybe it's a data mart instead of a data warehouse. So you create marketing its own data mart for its own purposes instead of the enterprise data warehouse for them. And there are certain reasons why you would do that. Maybe something marketing does is specific to marketing, or it doesn't fit in with the overall data warehouse. So you create one for just specifically for them. And then from the data warehouse, after you've loaded it, then all that work is finally rewarded and making it super easy for the business user to now consume that data. All the work behind it takes a Herculean effort sometimes, but the user doesn't have to see all of that. They get presented the data the way they need it. All right, so that's ETL, extracting from systems, transforming it after you stage it in some way, and loading it for analytical or even possibly other purposes. Like I said, Python is one way you can do it. You can definitely do it in SQL from those first few classes we've learned. But ETL using Python is it's very popular because Python is really flexible. So in some ways, SQL is flexible in the sense if you have it in a table or relational database, there's a lot you can do with SQL. Python is popular because oftentimes data does not already live in a relational database. And you also have Ronnie and Michael Jonathan, he covered pandas in the Python class, right? So pandas is actually really flexible. So that's kind of like the start of a relational table. If you think of kind of like that tabular format with rows and columns, and there's a lot of power in the transformations that you can do with pandas. A combination of pandas and NumPy. Sometimes it's more convenient because the data is not quite ready for being inserted into a relational database, just because it's not clean or it won't conform into like a first normal form or anything. But really, that combination of Python and all the libraries in pandas make it really flexible, especially for ETL and creating pipelines for data science projects. So like getting data and creating all the transformations you need, and then running the predictive models or the machine learning models. Python really gives you a lot of tools to be able to do that. So really, why Python for ETL? It's common language for data scientists, especially popular with data scientists. There are actually libraries for ETL. One of the things that we're doing is using libraries to pull data from APIs. Michael and I are currently working on that. It doesn't already live in a database or a file or anything. It lives through a web API that you connect to and be able to consume data that way. And very flexible. You can adjust them on the fly. And here's kind of like a little visual of how a pipeline would work is if you had Salesforce and then you use some libraries with Python. You could load that into MySQL. And then MySQL, you can just connect to Power BI, and then you have everybody who's really happy until they want more. So they're temporarily happy for a day or two until they want to answer new questions or need more data. So the example that we do today will actually take you through this process. So this will be a CSV file. You'll use Python, load it into our cloud database. And I didn't actually connect it to Power BI, but that's a fairly straightforward intermediate step that you can do. Once you have the data in a structured way in MySQL, it's fairly easy to connect Power BI to it. It's just a matter of giving it the right credentials and pointing it to the right place. All right. And actually, let's go ahead and take a break. I've been talking for about 45 minutes here. When we come back, we'll talk about data management versus DBA, and then data governance, data quality, and data dictionary. Sound good to everyone? I think it's a good time for a break. So we will 7:20 now, back about 7:35, 15 minutes. We'll finish up, give us probably 45 minutes to work on the class project today.
All right. See you in a few.
All right. See you in a few. Hey, I'm back. Yeah, one of the
Welcome back.
one of the challenging things about daylight savings time is that you have to resynchronize all of your clocks, the ones that aren't automatic.
True. And then you have to remember how does this one set its clock, right? It's not like there's a
Yeah.
universal interface to setting the clock.
The car ones must be the weirdest. They seem to be like the least intuitive. Like, all the buttons that you have to press and then spinning the dial and everything. It's like you're refiguring that out every 6 months.
I have to admit the coffee maker is one that stumped me because I had the clock or I had the menu, and I'm like, you're not giving me any options. But I got it.
Yeah, back in the day, you just have to say, I think my parents used to talk about people like missing work because they just didn't realize it was daylight savings time. And then all of your clocks back then are battery operated or some crank or
Or yeah, you had to wind it yourself.
manually wind it yourself. At least getting closer to the fully digital age. I think they technically call it the digital age now.
But we had fully digital clocks in our schools in the renovation, I don't know, back in 90 or whatever, but then they all have failed, the digital ones. So they would automatically set, when it changed or the power went out or whatever, they could do it from one location. Now they're all back up with analog. And mine, I could take off my wall and just, turn the little button to move it. I took my colleagues off the wall today and it was all like digital and supposedly syncs to the the server or something, but it was still an hour difference. And so tonight all the night custodians, I guess, have to go around and change all 100 some classroom clocks. Yeah.
Yeah, not as big a deal if you remember to do it or remember it's daylight savings time.
Right. But it
But
would be
now,
nice if they all did it together.
yeah, now you have your phones that obviously do it now. That's probably the
Right.
best. But I caught it on TV this weekend and kind of remembered that way if you don't catch it.
Mm-hmm.
It is kind of amazing though how many things have that clock to them and how important that is. Like even the seconds, right? I didn't even think about how important even the seconds are to communication. So even any of the stuff that needs to communicate needs to have accurate times.
Yeah, to send back and forth. Yeah, that's they have like the central servers you can sync up to now, but not always foolproof. Oh. Anyway, should we finish up this lecture and spend as much time as we can on the class project?
Okay, sounds
Figuring
good.
it out. I'm going to give everybody an extra 30 minutes considering I gave everyone their final exam here at the beginning of class. So if we want to work through 9, I'm good with that. All right. So let's knock this out. So we were picking up after talking about basically ETL and the flow of data through the organization and just the data management tasks that belong with master data management and so forth, and the types of enterprise data. So now that we're understanding that, we're talking about data management versus database administration. I don't want to separate the two. Although this is a pretty good picture. And I think why it gets some amount of confusion is that there's necessarily overlap with all of these. So I often call business intelligence and analytics kind of like the intersection between tech and business. And that's because it's often true, because here's the business side. You have data stewards who are helping just maintain the data and the business rules, business process managers. You have a database administrator who's really looking at the physical parts of the database server and like how to make these data structures the most efficient and how to keep that server running the best they can. And then this data administrator, the logical, this is often like a data analyst or someone with technical knowledge of the data who's able to fix and correct it, assess data quality. And you could see like the intersection right here is a data modeler. So when you create those OLAP models, so online analytical processing, you're oftentimes taking this role, the data model, the intersection between business, knowing the data itself, and then being able to physically implement it. So you've seen this quite a bit in this class as far as analyzing the data, building the data structures that you need to store the data, and then adding, say, analytics is adding all of the business value and the business rules and definitions to it to bring I call it taking data and turning it into information that's valuable to the business. It's really this centralized role. All right. So what is data management? So data management, and you consider this, oftentimes it's synonymous with data stewardship. It's the practice of organizing and maintaining data processes to meet ongoing information life cycle needs. It includes the creation of data, storage, processing, archiving, and data destruction. So really deciding on, given the business context, like how is it most appropriate to create the data? Knowing how it's being generated, then how it's most appropriate to store it, processing, archiving it. Often that's a historically, like when do you want to take the data offline and then bring it online at some other time? There's some considerations on that. And then when do you destroy data? So at First National Bank, because of credit reporting regulations, you can only keep a customer's credit history for 7 years. All of it has to be destroyed after that. So stewardship is making sure those type of things, ensuring that these type of things happen from the business, on the business side of it. So differentiating this from database administration. Database administration is the use of specialized software to store and organize data. This is a technical aspects of planning, installation, configuring, designing, migrating, and so forth, backup and data recovery of a database system. So oftentimes I've seen it in the past where database administrators actually aren't really that heavily involved in the actual data that's stored within the tables. They're more interested in the aspects of configuring the server, making sure it's performing correctly for its needs, doing security roles, providing data recovery, and so forth, making sure it's a properly functioning database. Especially important with application databases. I think somewhat important with data warehouses in the sense that a lot of users could be using the data warehouse and making sure they have access to the right data. If multiple people are querying the database, making sure the database doesn't break down. I've seen that happen in the past too, kind of been a culprit of that a little bit with what I've tried to do, but it's kind of the idea behind the database administration. They're concerned about the physical server itself, like MySQL in this class. So what are the similarities between the two roles? Both of them specialize and coordinate the database planning, goals, design, and communicate actions while the project is being implemented. So the database administrator does have quite a say in this project as far as like the goals, the design, the considerations that are needed for the project to be successful. Usually in these type of projects, Well, I think the best projects bring all these people together. It's not really just a database administrator making all the decisions. I think we actually talked about this a little bit as far as like bringing the business side. I think last week, bringing the business side, the technical people together with the business side and people. I think that the sweet spot is right in the middle of the people who own the data, know the data, and then are in charge of the systems here, communicating all their needs for the best solution instead of as the database administrator seeing it from their point of view or concerns. So then what are the differences? So data management focuses on the logical design, the planning, organization, and design of a database system. So this one, the data management piece, they are more concerned from an OLAP perspective of, designing the database so it answers business questions or theirs and it's easy to query and it works for the purposes and the questions that they're trying to solve. So the database is really focused on, like we said, the performance, the access, the backups, and stuff like that. So really the physical hardware versus the business needs and the logical needs. So what type of data you have within the organization. So really separating the roles, but in combination with each other is where the strongest, bond or bringing everybody together or the best solution lives. With BI and analytics, and even now data scientists, you could really extend DBAs into all of these new big data technologies to people who administrate these NoSQL databases or servers or Hadoop databases and servers and file systems and stuff like that. Really, they're similar to a database administrator in the sense that they're concerned about the systems, and the other two are considered about the data and how we answer the business questions, and then working together to find the best solution. Really, that intersection between business and tech. There's a good career to be made right there in the middle. All right. Well, focusing on the last pieces of data within an organization. So we have data governance and stewardship. So what is data governance? Data governance is a quality control discipline for assessing, managing, using, improving, monitoring, maintaining, and protecting organizational information. So data governance is really like, especially in the big organization where data governance has more influence, they're really the people who are defining like the use of data, some involved in master data management, security around data. So who is it being transferred to or not being transferred to? Really the process and procedures around data within the organization. So it's not all that this concept of data governance can change from organization to organization and what they expect from the data governance team and the influence they have. But generally within the organization, they're help defining some of these things, and it's really like a discipline around process and procedures and controls. So to do this in a organization that has a good data governance and stewardship roles is that they work directly with the data stewards to ensure that the data governance process. So they will work with data stewards to, make sure that, the process, policies, and procedures that they're creating make sense for the business, and the data stewards should give them feedback about that, about some of the best practices and some of the data that's being created within the organization. So a data steward is a position within the organization that ensures governance processes are followed, guidelines are enforced, and recommends process improvements to be made to data governance processes. So data stewards are also, they're really like giving feedback to the data governance team and recommending improvements to the protocols, but they're also helping enforce some of the usage of data. And because oftentimes these people are some of the business experts, they often come from like data champions from each department. Is a data steward someone who knows the data, someone who knows the business operations. They are also within their departments and within the organization, making sure some of their data is used correctly. So I think on the previous slide, they really talked about the business, the ownership of data, and that's what data stewardship is all about. They take ownership of the data. They make sure it's used properly in the organization. They have some guidelines to enforce it. Data governance does to some degree too, but they're working together really to make kind of a powerful team within the organization. And you'll often see these in bigger organizations, especially with a lot of data and a lot of usage of data. Not so much in medium-sized organizations, but bigger organizations where splitting up these roles makes a lot of sense. And you have that oftentimes have that type of specialization in large organizations too, just because of the sheer amount of people that are there. Right. So those are roles of data governance and stewardship. And then measuring data quality. So data quality is important for all the things that we talked about before. And I covered this. Completeness, consistency, and accuracy and validity. They have a couple of them here. We talked about uniqueness as far as like first normal forms and removing duplicates from data. And then they have a timeliness. So how often is data delivered? That could this one at least has that quality too, which I guess partially data stewardship role, but data quality can also come into play there. All right, so measuring data quality. What is data quality? So times errors or incorrect elements are present in your data set. It's important to be proactive in cleaning data and periodically test for inaccuracies. Even in the best systems, like sometimes somebody just uses the system in an unexpected way. Sometimes the system itself just generates an error, like just because of, for just some process or faulty logic or too many transactions at the same time or whatever. Hardly any system is ever perfect. So being able to identify those and clean the data periodically for those extract, transform, and load steps is really important. Being able to proactively do that and do that ahead of time before people start to use the data or a lot of it's generated. Right. So what is a data quality assessment? So you can identify these errors and understand their implications by both qualitative assessments and quantitative assessments. This will improve data process for quality and effectiveness. So quantitative assessment, I'll show you some code that does this in Python. Basically, you're taking a look at things like the distribution of data. If it's numeric, like what are the most common values, what's the median mode, and things like that. If it's categorical, you're looking at frequencies and how many nulls are in it, and so things like that. The qualitative assessments are really just business assessments, like making sure like the values make sense that are generated, having somebody like a data steward take a look at them, making sure nothing weird's being produced, everything has some type of label or effective business rule, and so forth. It's really a joint effort between people to do this. Often data governance and data stewardship, data stewards also. All right, so what's an example of measuring data quality? So I said some of these things, but oftentimes it could be like metrics or almost a scorecard of the known number of errors in a data set, such as missing, incomplete, or redundant entries. So missing values, redundant entries, duplicates. So fewer errors while the data or while the size of your data set stays or the same or grows, you know that organizational data quality is improving. So it's hard to ever be perfect with data because things come up that are unexpected, that you've never seen in the data before, errors you didn't anticipate or new errors. Some of that's, I think it's just part of managing the data and understanding the data and continuing to update and improve it. So almost all organizations, the data continues to grow and grow. So if like you're having the same amount or less errors as your data profile just grows, that you're improving is from a data quality standpoint. So like your numerator is staying the same and your denominator's growing, so your percentage of errors is going down. I think that's generally true. So it can depend on what type of errors you're getting. Also, if it's really critical financial errors, of course, those are more important than something that's less important in the business. So you have to take some of that into account too, and make sure, like financial ledgers, it's my philosophy that anything doing with finances or money, it's that much more important to make sure that those are correct over something like mailing addresses or something like that. The business value is much higher for those to be correct than others. So in general, though, I would say that the statement is true, but I'd also make sure that there's high data quality on the most valuable data assets within your business, and trying to ensure that. So data quality using Python, you can also do this with multiple libraries. There's a library that I found that specifically used to clean data and run summary calculations that I talked about. It allows you to load data into a pandas data frame and infer the data set schema and generate a summary. So I worked on this code before class. I haven't used it in a little while. I didn't get it to work on the project data set, but I'll show you a different example that generates summary report. It's a Zillow data set, and you can go out here to the Jupyter notebook and see the code that's created. And I'll show you some of the summary. We have summaries in the Excel files of what the data quality looks like here. And we'll do this as kind of part of the class project or final exercises for these PowerPoint slides for this lecture. All right, so data dictionary. What is a data dictionary? I would say this is also another thing that's a joint effort between data governance and data stewards, and maybe even data stewards to make sure the data is coming from the right source, or they know the source where it's coming from. They know what destination it is. Is it going into a data warehouse, or what table is it being loaded into? And then the business rule or transformation that defines it. So oftentimes the data stewards are responsible for the data that's generated out of their systems, the business rules around it, making sure it's usable for the rest of the business, and working with data governance to help define that. And data governance can also help with the data dictionary and these type of efforts, and making sure data quality is enforced and these rules are enforced also. But so anyway, what is a data dictionary? A data dictionary is a collection of sources. So where the data is coming from, the names, definitions, and attributes that define data elements captured in a system. So like the names are something like source column names and destination column names. And attributes would be some of the values that are within those fields. So like a marital status field may have single as S, married as M, divorce is D, widowed as W, and so forth. All right. So it helps define all those things and really helps keep track of data in an organization, especially as the data profile grows and grows. And some of these things become more ambiguous, like first names that are coming from different systems, like that end up in the data warehouse. You'd say, well, what system did it come from? What's the context behind it? Or even marital status is being defined differently and things like that. So more important as the data profile grows, that people understand where this data comes from, how it got there, and all the transformations in between. All right. So the data dictionary contains names and physical information of all database schemas, tables, and fields. The system of record. Oh, there we go. System of record, the source information. So where did it come from? Table constraints such as primary keys, foreign keys, and so forth. So how are the tables related if there are table relationships between others? In business, especially the business rules, transformations, and metadata about the field values. So all of this is related to OLAP. So how are you extracting data out of systems and how are you defining it? What are those transformations that you take from extraction, transformation, all the way to the loading into a different database or different system, in a big catalog of those. So especially helpful. A story back to when I worked at First National as for the first 9 months, I primarily worked on a data dictionary just to be able to document and understand all of the different fields and what they meant and what systems they came from and the different contexts of the data. And it was just tremendously helpful to help navigate just like everything that was available to me, to like be able to put together reports or dashboards or financial projections or whatever. So it really helped as a guide to understanding the data and knowing where it came from, and what, like, given the question that the business asked, like, what information should I be getting like out of all of this, like, and the data dictionary would help guide me to that. Questions about the last couple slides, the roles of data management, data governance and stewardship, data quality, data dictionaries, all kind of part of that bigger effort of just the maintaining, like, first storing data, so being able to get the data out of systems. So going back to just the title of this lecture, the storing the data, so all the way from just getting the data and loading the data into the data warehouse for the first time, or whatever OLAP system or data model that you're using, to just the management effort from the perspective of data governance and stewardship and data quality and data dictionaries and so forth. It puts a discipline around the big effort of managing data within the organization. Make sense? Any questions? So I always try to convey how much of a large effort this is. I think it's an underappreciated effort within the organization. Everybody's like, well, the data's right there in the system. Like, what's the big deal? But obviously, there's quite a bit more to it. Even if you extract that information out of the system, it may not kind of come out in that format or that context, or really it depends on like what question you're trying to ask too, where like, are you going to have to load it and then join it with other tables in the database, like blend it with other information or from other systems, which is often where like the best insight within the business comes, is that you've taken two different disparate data sources and you kind of combined them in a way that uniquely answers a question, or a question that like is hadn't been straightforward before, but now you kind of see it in a new way, which leads you to new insights and new questions. And I think that's really like, I talk about it being a large effort, but that's also when you know that when your initiatives are being successful, your business intelligence or your analytics or your data science, is that people keep asking for more. So I know that sounds like kind of straightforward, but like they like really you provide data to them in the right way the first time, and then they start asking the right questions about it. And then that leads to bringing in more data or new data, which of course becomes a bigger management task. But if it is providing the right value, then it can be worth it to hire another person or get some software to help you manage it or do whatever you need. All right. Ready to spend the last hour on working on the class project?
Here we go.
Let's do it. All right. All right. So this milestone is, it's really a combination of the class project and creating a data dictionary. So a combination of exercises from here and creating a data dictionary for the project. So tongue twister, say combination of exercises for this lecture and work on the project. So the exercise here is to create a data dictionary for the consoles schema, which is also known in our MySQL database as class project, highlighting the original data source, database schema tables, field values, types, and business significance. So all of the things that you would see within the standard data dictionary. And I'll load this. I'll show you where you can find this. It should be inside a class project. And you'll see data dictionary consoles. And you'll start to see some of these fields as far as the source data names. So what files you're getting them from and the name of them. So the table location. So these should be, I named all of these consoles from a previous project, say it'd be class project, but it still holds. You have the console dates and the console game sales table, the column names, the format of each one of these. So where the data dictionary even really starts to add a lot of value is you say it comes from this source, and what is the true What's the true business description here of this? Hold on one second. Just moving that around. What's the true business description or the business context of each one of these fields? So it's even things like platform name is a short name of the video game console. First retail availability is the earliest date of retail. Like some of them are straightforward, but sometimes it could be a little less obvious, like platform, like let's see, genre, date. I guess there's this one is the platform comment is the full name of the video game console. So it could be a little less apparent also. And then you could see the values that are in the field. Say like genre has fighting, action, shooter, puzzle game, role playing. And you can add some notes to say, is it a key field or not a key field in the table? So this is really valuable, like I said. So like my time at First National, you literally had a data dictionary that had probably 150 tables and maybe 2,500 fields to choose from. And then you're looking at all these tables and you're like, well, really, like, what's the field that like answer this business question that I should like really be looking for? And this is so there's some nowadays, there's some nice tools that help you catalog all of this stuff. We're kind of looking at some of that in Azure, Michael, with Azure PeerView to be able to classify, to look in the Azure ecosystem and classify all the data sets and fields and as a tool to help you define all of this. But there are other tools that organizations use too, but I did this in old-fashioned. It can be done in Excel, and I did this in old-fashioned Excel at First National. But you're just looking around and you're saying, what's like out of all that, like what's really the right field that I should be looking for to answer this question? If you have good business descriptions and values and things like that, it helps narrow it down greatly for what you should be looking for.
Definitely.
And even you could create a data dictionary that defines KPIs. So your key performance indicators. You could have another tab that has the, top 20 KPIs in your business, or usually it's less than that. Like usually you'd want like top 10 or so, but like what fields comprise those, and how do you really calculate these measures across the organization, which can be really helpful too to make sure you're doing an apples to apples comparison across different business units. I'll never forget one other time I was working at First National. Like I learned a lot from my first experience with data. Like I'd recommend for people taking this class just to try to get in somewhere as a data analyst to start. Just start working with data because you learn a ton about it in the business. But I was doing this report for marketing. I usually worked in credit card operations, but marketing asked me for a report. So I created this report. I can't even really remember what it was right now, but it caused some amount of controversy because it's not the way another analyst created it who actually works in the marketing department. So like the question was, well, you could have gone to that analyst, but but then there's like a bunch of time spent saying, well, how did you calculate this versus how did you calculate this? And that works for credit card operations, but it doesn't work for marketing. And usually we would exclude these things, but you were including these things and excluding other things. So having like just these KPIs and defined across the organization is also valuable. That can be part of the data dictionary also. That's one of the big initiatives while I was there at First National is that we were producing a lot of reports and data, but there's some disagreement on what the calculations should be across departments.
Well, it's interesting too when you look at reports and someone goes, "Well, I want to compare year over year." Okay, so what is year over year? Is that exact date of the calendar year over year? Is it week of the year? Is it adjusted around holidays? Yeah, so it's interesting how something that might seem pretty obvious gets more complicated as people start expressing their viewpoints, their perspective for what it would mean for it to be an accurate report.
Yeah, or sometimes it'll get weird. Like you'll be doing call center operations, and somebody will be like, "Well, our call center doesn't work on Fridays," or or like
Right.
every other Saturday or something. So that's like why one is higher than the other.
Yeah.
Or something just a difference in operations, but difference in the difference in business rules can be a big thing that help data dictionary and data governance and steward uh, efforts help with.
Right. In this location, we celebrate that holiday on 2 days versus just a single day. Yeah.
Oh, I know what one of the big one is. So you observe different holidays. Um, so at West, they had call centers in overseas, offshore. So one of them was Makati in the Philippines, and they observe different holidays than we do. So
Hmm.
like how you even look at time ranges
Right.
can differ, right?
And in China, some holidays are celebrated over the course of a week instead of a day or a couple days. And so what they do is they move their work week to the week before and week after. So they'll work the Saturday before and the Sunday after so that they can have a full week off. And that's typical
Yeah,
across the country.
yeah, yeah. I
Anyhow,
think the business rules are there too around the KPIs, and that sometimes it even just comes down to how one department defines profitability versus another or something, what they're including or excluding.
yep.
Or actually, well, the business rules, yes, but even like the definition of the calculation itself can be different on how they calculate profitability, like numerator and denominator and stuff like that, or whatever metric they're looking at. That used to be a big thing with marketing campaigns. That was it. Like credit card finance would look at a marketing campaign, but it's not really the way marketing looked at it. So they had to get on the same page or they disagree or whatever. They'd have big disagreements over it. Because they're like, well, in this context it's true, but that's not like the way we look at it. So
Right. And there's never money on the line.
yeah. That's sometimes why you create a data mart for a department also that eventually that you can roll up to the enterprise level. But at some level, you have to have some agreement on them. Probably the worst situation I've seen is it's almost like the definition, how they define the KPIs is that they just toss KPIs at every department, but they actually worked against each other. Like
Mm.
the sales, say inventory and sales KPIs worked against each other. Like you'd want to have low inventory management, but make sure that customers always had inventory on hand or something. So, so like they're each like they're chasing their own competing KPIs within a business, which is like its own KPI design problem, but maybe that could also be like flushed out with something like this instead of having like 300 measures that you measure people on. It eventually will obviously conflict with each other. If you had it all down on paper, maybe you could review it and you'd be like, oh, yeah, it doesn't really make sense to have those two competing within our business. Those are on a side note, those are the weirdest businesses too, where it's not like you're competing with another outside business. You're like actually literally competing between departments within the same business.
Yeah. And
Crazy.
that's not a win-win. That's a win-lose.
Yeah. So data dictionary, this effort and discipline kind of tries to bring a holistic view of data to the organization, which I think personally, I think that's the best way to look at data in the organization and to use data within the organization. The ideal is that it's open. It's more or less open to everybody. Like some people aren't going to want to know about all of the data in the fields and stuff like that, but essentially that data is used to drive business results across the organization, and it's open to management or anybody who wants to use it to drive those results instead of to fight against each other. But yeah, this was the idea. That's the idea behind data dictionary. I also have within examples, there is one for an ETL pipeline that will load data into MySQL database. So this one, let's do this by, we're going to sort by date. Oh, did I upload it today? Yeah, this one. The ETL Python to SQL books. Oh no, that's SQL file. This one. ETL Python to SQL.python. Say, Ronnie or Michael, do you have Python installed? Happen to have Python installed on your machine or Anaconda?
Yeah.
Mm-hmm.
So you could open this up by Anaconda. I can show you. I'll show you how to do this. Yeah, probably not that way. Let's download this one and there's a CSV file that goes along with it. Let's just download this one first. So you should find this. It'll likely be in your download folder. Oop. I'm going to say keep. So it actually downloads.
So we're downloading the...
You had the examples.
Okay.
Yeah, the ETL Python to SQL.
And then do you want us to do the books and the book clean CSV too?
I believe it's the books file. Let me open this. So I use Spider out of... James got me hooked to using Spider out of Anaconda. I think
did he? All right.
Jonathan likely uses something different. Doesn't he use...
Jupyter Lab.
Oh, he uses Jupyter Lab? So he uses notebooks?
Yeah. So you like Spider, huh? I'll try Spider out.
Yeah, it's good for running things. And then you can really see like the different data frames or what's in the variables. But it's a Flickr images book.csv that you'll want to download. Images book, not the book cleaned, because that's the output. What did I do with that file? Hold on 1 second. Here.
Sure.
I'm gonna put that file in there.
Oh, is it the BL Flickr images book?
Yes. Is it in there?
Yeah, it's down at the bottom.
Yeah, BL Flickr images book. You'll want to download that.
Okay.
All right. And in here, in the code, you'll want to change it to whatever path that you downloaded that CSV file too in the path variable. So all of this is just a remind is
Gotcha.
this is all of an example of how you can create an ETL pipeline using Python and then upload the results to MySQL, the MySQL database. So I definitely find Python pipelines useful if you're just reading like Excel files or CSV files or just some type of file like that off of some type of file structure. Or some file hierarchy like Windows folders and stuff like that. So if you run this, you'll see some results. If you do df.head, I kind of see the first few rows and it'll look like that. Yeah, I'll expand this a little bit. You can kind of see the first column, the identifier, and then there are a bunch in between, and then what's in the shelf marks column in this file. And this file looks like, let's see. I'll open this up so you can take a look at what this looks like. It'll look like this. So it's for Flickr book images. You can do, it has like identifier, edition, place of publication, data publication. And you can see it's a little bit of a messy file, or at the very least, it might not be in a format that you necessarily need it to be in, like this data publication. And maybe you just want to clean up or do certain things or find certain authors in this file. Pandas would be perfect for that. And then you have Flickr URLs and stuff like that. So really all this file is, it's kind of like just an example of all the different or some different things that you can do. So you can import this and drop some columns. Maybe you don't want all the columns in there. Then you could take another look. So it's down to 7 columns. I'll expand this a little bit so it's easier to see. And what I like about using Spider is that now you can see, like in your data frame, you can double click and you can see the data that's being loaded. It's really handy for like building pipelines or doing analytics and stuff like that.
That is cool to see the data frame visually like that. I like it.
Yeah, and then like each step you can see like what did each step do, right? And how did it apply to the data set?
Well, and it looks like there's debugging functionality in here too, where you can step in and step out.
Yep.
Nice.
Yeah, you can create this just like a Jupyter notebook and run each one of these as cells. So it's basically like a Jupyter notebook just inside the editor. We do some other stuff here, so making sure that there aren't any duplicate identifiers. You get the shape and the shape of the data set, like the number of rows and columns. Get the data types for each. Get the data types for each field. Just kind of the stuff that you would do when you're analyzing and cleaning up a data set. Let's see. Combining string and numpys to clean columns. Just cleaning up some of those descriptions, just providing an example. So if there's an item, just going through iteratively inside of a data file and then changing that name to my name and stuff like that. So really like in SQL, and in the next class, I'll show you how to do a stored procedure. That's really like a more iterative or step-by-step way of cleaning up a data set. Really like, you can think of SQL as a query language, and it's a bunch of row and column operations. So you're either applying something to a row where you're applying like a summary function to a column. Whereas the advantage of Python is that really you can do like these different things step by step, and it's like you can iteratively like do this to each row or different columns within each row, as opposed to like a set of rows or a bunch of values in a column or stuff like that. So there's a bunch of stuff that you can do in here. The other file that you saw, once you do all of these, you'll get a clean data file, which is the one that you saw. Of course, it didn't work for me. Let's go back and run this from the top. What's kind of nice is the interface is simple. It's kind of like, the MySQL Workbench, in the sense that you can just highlight a bunch of the code down to where you want, and then you could hit the play button up there. And then it's output that cleaned version. And Ronnie, if you have any questions here as we go, let me know. Or if you're following along.
I'm just kind of following along. I'm still trying to conceptually get the Jupyter and I get the sense of what it does, but I'm not real fluent in, the Spider or Jupyter.
I think I might have this in a Jupyter notebook also. I'll take a look at that next. Or we might be able to load this in there. But anyway, we have a clean file here. And then we can take this clean file and import it into the MySQL database. So think of this as we initially extracted data out of this file. So the E part, ETL, we did a bunch of transformations to the data that we wanted to clean it up and make it conform to how we want to see the data and to insert it into the database. And then we're using the PyMySQL library to be able to load it into the database. And Michael, you are likely going to need to run this command right above it.
Yep.
The pip install MySQL.
Yep. Yeah, I ran into that error and opened up the console and ran that.
Yeah.
What I need now is your password and your credit card number so I can do the access.
I was careful not to put mine here, but this is where you start to enter your database credentials. So you enter your schema or your login name, and then your password. And no, this one's a schema that you want to use. So this would be like J Bergman. You said, and then whatever your login password is there. And then this will be the host and your login username with password and schema. That will get you connected to the SQL database, MySQL database that's in the cloud. Or it should, I hope. Let me know if it does, Michael.
Oh, sorry. Let me get my.
I think it should. I think I got all these settings right this weekend.
Okay, workbench.
You know that I put my Mountain Dew somewhere. Oh well. And you could create this type of pipeline for the class project also. You could take one of those CSV files, clean it up, create your database table like I'm about to do down here, and then insert those records into the database table. So instead of using the MySQL import wizard, you could create a Python pipeline that did all of that for you, that cleaned up the data and did it for you. Let me know, Michael, here if it works for you in a minute.
Okay, trying to remember which password I used.
It's been since like the beginning of class. You set it and forget it.
Right, pretty much.
I actually did that with, I created a new user account and I already forgot the password. Hey, I have the power to reset it though if you need it.
Yeah, I was hoping I could somehow.
I might actually reset my new user password and let you use that. Administration.
Oh, my keys. Login. I'm looking for.
Okay, I just changed the password for this one. So if I do schema new user, password is welcome 21. Oh, user password. Oh, user. Change that user to new user.
Okay, so I confirm that my password's correct.
Michael, did you get that saying that error? Access denied.
Yeah, access denied.
Using password is equal to yes. So you confirmed that you had the right password?
Yep, I have the right password. How can I check on my user? Actually, I should go back to that. So I don't know if this matters, but my schema and my user are different. But
Yes, it would. So let's see.
actually, something's not right with my password. What I had saved in the keychain is not working now.
Let's see. Disconnect. Well, M Fiedler is that the username I gave you?
Yeah, the username's M Fiedler, but my schema is M Fielder. So the D and the L are transposed to my schema.
Oops.
Yeah, no worries.
Can
I
you
was gonna say something, but I'm like, I might need to have my password reset because the ones that I thought it would be not working.
Okay. You want to send that? However, you want to send that over to me, Michael.
Sure.
I can do it for you.
I'll text you.
Okay.
How's that?
Should do. Let me log in here. Okay. Administration. Can change this up. Okay. Okay, apply. Okay, I applied that, so give that a try, Michael.
Rock and roll. So I got the editor to work, so let me run the script. Create command denied to user mfiedler at IP address for table ETL books.
Okay, I think that you'll have to create or change that create table schema right there. The schema.etl book.
Okay, now I can see you. Okay. Change what?
So now what we're doing after you make the connection is that you can, now that you're connected to the cloud database, you can actually run a query. And we're going to run a create table query to create this table to store the data. So what you need to do in this, though, is change that from new user to mfiedler.
The LDER version, right?
Yeah, yep.
Boom.
So
Yep.
now if you refresh this in MySQL, you should see, and I could actually have the power to see everyone's schema. If we look in mfiedlers, yes, the ETL books right there. And then he has all the columns. He has a primary key with identifier and then all these columns here. Is there a way to, not a great way to make that bigger for everyone to see, but it's there. That command worked. And then this last one, basically what it does is it reads this cleaned file row by row, and it's a insert into statement by each one of the values. So remember when we did that in class 3, where we inserted like those long records with the parentheses around them? We're doing that. We're just looping through each one of the rows in the CSV file and inserting them one at a time. Because you can see it's even the same structure. Insert the ETL books, and then you have your column list, and then you take each one of those values. in this CSV file. For row and CSV file, execute this query. So it's actually doing this insert statement like a whole bunch of times in a row. Now there are other libraries that you can use in pandas where you basically are doing like a bulk insert instead. So it's almost like a query, and like we saw, query-based insert, and you can insert it that way. But this is one way to do it. Just want to illustrate how it works. And then it'll actually take a minute or two to, probably a couple minutes to do, because it's 8,000 records. And then you could actually check your results here too. So the idea is that you can do all the cleanup in Python, and then your load you can actually use a MySQL library to connect to this cloud database, create your table, including the container you want to store your data in, and then load it all in. So that's why Python is so handy to create ETL pipelines out of it, because you can import all these libraries and do just about anything that you want. The only problem with SQL's not bad for this stuff at all. The only bad thing is that, of course, to use the SQL programming language, the data already needs to exist in a table instead of in a CSV file or Excel file or a web API, REST API, or something like that. So at work, we literally have pipelines all over the place, Python pipelines, probably too many of them. That's the only bad thing, is that they can get kind of crazy with them.
Yeah, we can talk about
how to manage it. But we're moving all these over to more visual, low-code pipelines too. So there are tools also, Ronnie, that you could use. And we're doing some of this in Azure, is to replace parts of this Python code and just do visual pipelines instead that do certain things. That will extract the data, do some of the cleanup, and export it to wherever we want, or Power BI, or we're building a data warehouse very slowly. We keep getting distracted. With
and is it Azure or Azure? We use that in OPS. I think it's all like
Azure.
Single sign-on. Is that where it would be in a system like ours, where you got everybody's username and password for all the different applications they have to use in education?
They have it all they have it single sign-on in Azure. That's what you're saying? All their systems?
Well, I don't know. It's spelled the same. We call it Azure, but I don't know if it's the same.
I guess they probably moved whatever they could to the cloud too. I wouldn't be surprised.
And I don't know if it's the Clever is the application, but Azure tracks all the devices, or I'm not quite sure.
Know what? There's like an Azure Authenticator or something like that. You have to use that, like it gives you a code and everything.
Yep.
Yeah.
Yeah, every time I sign on to my email, I have to have my phone with me to say it's me. Mm-hmm. Mm-hmm.
Michael, did that load for you?
Yeah, I believe so. I just couldn't do the select.
Oh, the select didn't work. Let's see what the deal is with that one.
I can write again.
Change the schema, the system. Change it to the misspelled Fiedler.
Okay,
Fiedler.
I got you. Now, is it going to try to insert again, or just ignore that failure?
No, it won't try to insert again. Run these two statements below, and it should close the old connection and open a new one to do the query.
Guys, how do you protect your eyes from staring at these computers all day? Mine by 9 o'clock tonight after 8 hours at work, and then another. I'm like, my eyes just burn.
I have been looking at this all day too. I don't know. I guess I just got used to it over time.
Yeah,
Well, that's why I didn't know if it's just the older I get. I mean, I know I got allergies, but I can't. I mean, I put on a second pair of glasses just to stare at this, but I can't even see the screen. I mean, I can see what's happening on the screen, all your code and the line numbers, but to replicate it or do it on my side, I could not.
I think the screen's just burned into my eyes at this point. This is how it works.
But Michael, you have glasses on. Do you have special glasses for screen or not?
I do have a blue screen in it,
Do
like
you?
a blue tinting or something for these. Yeah.
Because all mine are cheap readers. I just need them to see close up. I can see far away, but I can't now. But
Hey, I know
by
it's
after,
Yeah, I know it's not commercial time, but I have to tell you what, Costco, like my kids joke that everything in our house is going to be coming from Costco, but I've got
right?
another case where I'm like, I'm singing the praises. So an entire eye exam, including taking pictures of my retina, which my wife, when she did it someplace else, was by itself $80. I got a full eye exam with those pictures for $90 at Costco. And then I got 2 sets of glasses for like $400, I think. And the last time I did that going someplace else, it was over 600. So I was like huge, and I've got frames that fit me. So yeah, so I'm like Costco. First stop for everything is gonna be Costco.
Yeah.
I did that years ago for cheap contacts. An exam is cheaper than anywhere I could go.
Yeah. Yeah, I'm just like, that's fantastic.
Yeah.
See, the nurse used to tell me to stop reading the the eye chart because I could like X-ray vision when I was a kid. Like, you really shouldn't be able to see that bottom line. I'm like, I could see, but when you hit that 40 and then everything starts to, get worse. But all I need the readers for is because I can't hold my palm or my phone far enough away because I can't see close up.
That was a shocker for me when they said, "Hey, why don't you do this?" I was like, "No." And I'm like, "All right."
Yeah. I mean, my monitors at work are 3 foot from my keyboard. They're clear back, and people come into my office like, why are their monitors so far away? I got to look real close. I'm like, because I can't see them close up. I can see them further away.
So that's the thing, to develop farsightedness. My wife's is doing that, actually. She's just right at that age, being 40.
Yep.
So to answer me, Jeremy, yes, I have the first row of result displayed.
Did that query work there?
The select did execute. Yep.
All right. Mine's not working for yours because I used the new user credentials. That's why.
Gotcha.
But that's the ideas of how you can do ETL. You can this is actually combining the best features of ETL in Python. So being able to read in a file and clean it up using pandas, and then using SQL, reading it into a database using SQL and the PyMySQL library. Pretty nifty. You're actually combining the power of both.
I know, and I want to know who wrote that. That
Who wrote
library.
this? Oh, this library, the PyMySQL.
Uh-huh.
Oh, somebody
It's probably out on the website.
Somebody probably did it the hard way first and decided to create a library out of it, right? Here's a project. Who did this one? Usually they say, so it's in GitHub. This guy, Yutaka Masubara. A lot of these are on GitHub and open source, so people contribute to them.
Mm-hmm.
Somebody creates the original one. Like there's developer communities. I wouldn't really call myself a developer, but like I always thought it'd be kind of interesting to contribute to one of these developer communities. There's a lot of that with cryptocurrencies.
Mm-hmm.
They're a lot like that. Some of them they're supposed to be decentralized by nature, so like everybody collaborates on it. It makes offers up improvements and stuff like that. Or you could create a fork in the cryptocurrency and make your own cryptocurrency. It's kind of intriguing.
Which some people have done. Yeah.
Which, if you have the skills to do that. But yeah, somebody probably basically started writing a library and then they put it out here. And then, like, they just allowed people to improve on it, right? And there's some people who maintain this thing, right?
Mm-hmm.
It's kind of interesting. These developer communities, kind of interesting.
Yeah. Try to understand the motivation.
Yeah, people just like to do it, huh? Like what they do with their free time.
I do. I think they do. And then I think they hope, okay, what can this lead to? Can this lead to a book? Can this lead to a different job? What can this lead to? So it's interesting the different the plethora of motivations that people have.
Yeah.
Including just the thrill and joy of doing it.
Yeah.
Mm-hmm.
I want to show everybody one more thing. Say we're gonna have time on Wednesday to finalize the class project. Did either one of you have questions about the class project or where we're at before we?
Only a small question, and it's a little bit of an assumption I probably should have voiced sooner. Are you intending for us to do this individually, or are we doing this as a group, as the class project?
We're kind of doing it we've been kind of doing it as a group.
Okay.
Along the ways, the different steps, like here, this is out of my folder, but it's the same. Like in the class project, I've been putting together like the different milestones and what they look like for everybody to follow along. So probably a combination of just running it and working a little bit on your own and understanding how it all works. And I've actually loaded this into Power BI workbook for all of us to work together on Wednesday.
Okay.
There's tables in the class project and recreating the ERD diagram.
Cool.
And then we can answer those separately and see what we come up with. I
And
have a
did you
couple questions. It's kind of like answering the initial questions about the Barbie adventure game.
Did you update the class project PowerPoint since
I did.
class? You did? Okay.
Did I update this in Google Drive though? Let me see. I actually just updated it.
Okay, because I thought
this weekend.
step 7 or whatever on the.
Yeah, I renumbered these.
Okay.
So
So
that
then
yeah. Let me see lectures.
Well, and I was just going to try to take myself through it and do my own little project, but that's what my motivation was. But grades are due tomorrow, and I want to.
Oh, you can by all means do your own project after this.
What's that?
You can by all means do your own project. This isn't really graded or anything, but you might be running a little short on time.
Yeah, but I was using the steps or trying to, kind of follow along and just see if I could,
Yeah.
But I may have
the
questions.
steps should basically in the project more or less apply to any other project that you do.
Right.
Okay, I updated. Let's see. Yeah, I renamed these, right? So I just went through like the lectures and did 2 for 2, 3 for 3, 4 for 4. So milestone 2 is class 2. It has it's missing a mysterious milestone 1, but I just made it the least confusing. I consider milestone 1 is getting set up for the class. Maybe I could put that as 1. But basically, the last class will be answering these questions if you think it's a good idea or not. And what are the most popular ones? What are the most pre-orders? What has the most pre-orders? And do you think that's a good idea? If not, what suggestion would you make? Kind of like that last part of taking all that work you did behind the scenes to get to that point, and then like answering the question and making a recommendation to business. Maybe an appreciation for just all the steps in the project and all the work that it takes behind the scenes to get to that point.
Right. How easy it is to ask the question, even great questions, but how much work it takes to answer it quickly.
Isn't that the truth?
Yeah. No, that's why they usually say 80% is like the work behind the scenes, the data work, whether it's just like loading or cleaning it or managing it or whatever. And 20% is like the analysis or building the predictive model and presenting the results. Kind of the way it is. Technologies maybe some technologies in the future will automate some more of it in their libraries for Python libraries for cleaning and stuff like that. But and more visual tools, we're getting there a little bit. If you want to see some of those, that's in the extra lecture that I have. Some ETL tools and libraries and things like that, cloud technologies, alternative database storage makes some things easier. Oh, I was going to show everyone, last thing I was going to do was show everyone that data quality review, wasn't it? Yeah. Before we go.
Okay.
Michael, I forgot, did I just answer your question or not? I think my energy drink's wearing off.
That's right. I think you did. I think I'm in a good place.
Oh, were we all doing it together? Yeah, we're mostly doing it. I just recommend, if you haven't, just running through everything at the end of each one of those lectures just to make sure you're caught up.
Like a good checkpoint. Sounds good.
Yeah, and then the last lecture is basically just loading it up in Power BI, recreating those relationships, and then answering the business questions.
Cool.
Like the final step of all of the hard work that you do in this class and otherwise with the data. So examples. I do want to show one data quality example. So there's this code. I didn't quite get it to work. There's something that must have happened to the library over the newest versions of it. But inside of data quality and test, if you go to output and you take a look at something like data compare properties, this one actually compares both the data sets together to find the differences. Let's see, column 1 and column 2. So it does things like it tries to define the data types of each one of these. So it tells one of them's key, strings, and numerics, how much they're correlated. So these are two different data sets. It's comparing the two data sets together. And then it just does a bunch of summary statistics about each one of the columns in here. So it's pretty nifty for, I think one of the things that when you're doing data quality, and this is what I was talking about, the different values, like the min, median, and modes and the distribution of values. And this would be like basement square feet. It's just really in data quality, you really want to profile your data set and understand your data set, whether it's the distributions or like missing values or the different categories in your data set. And then create your data quality rules from there, making sure that it meets certain standards or thresholds for it. And and this type of analysis is also really important for when you're creating predictive models also, to understand the variables or the columns that are in the data set and how they're distributed and how those would impact creating machine learning models. Because you don't want a whole lot of machine learning or missing values, because those have an impact on the models that you create.
Right.
So pretty much it for tonight. I kept everyone a little bit longer, but trying to make up for it there. Finish up the final exam on Wednesday. If you want, Ronnie, I'll give you a grade. Make you feel.
Yeah, if I can get it to that point, I got to get the course guide out in next year's schedule by December 1st. Not next year's schedule, but the course catalog, so kids can select which school and what courses. So.
Yep, because they're signing up for classes.
Yep, and we got a whole new set of pathway stuff. So I'm in the middle of course catalog creation, and
awesome. Ronnie, did you say that you said the South is starting up some of these additional tech classes?
Yeah, our data, it's kind of our technology and data science, but having the teacher and the everything coordinated, with the course description and all of that. And that's part of me going through, these classes to see, how we can line that up and offer that to be unique, compared to, technology's offered in all the high schools, but, cybersecurity used to be the new buzz thing or whatever. Well, now all 7 of the OPS high schools offer cybersecurity and, the 2 new ones as well. So just, again, trying to kind of stay ahead of the game and lead in a different way in technology. So
I think that's awesome. I wish I had that kind of opportunity when I was in high school.
Yeah, but it's going to have to take, people like you guys helping teach it, because you know as well as I, to get a teaching degree and be certified in the schools, we're going to have to, we're eight teachers short right now of the 150 that I need to teach. So I got classes combined. I got, let alone to have specialty teachers that, the colleges aren't putting out. They're putting out math teachers, science teachers, English, but they're, the data folks like you two are out in the big business, not in the education field teaching others about it.
No, keep me in mind, because my heart's actually in consulting, so that's how I got
Yeah.
started in contemporary analysis. So
Mhm.
with my current job, not that I won't be there for a while, but just keep me in mind and feel free to email me, and if the class develops.
Yeah, and that's what just working with Nate and trying to, keep this because he's worked with the State Department too. I mean, we're trying to get the whole pathway, developed because it is, to increase the job, skills in our Metro Omaha area, and so we need to start encouraging it and teaching it, at the middle school and high school to at least let people be familiarized with, all the stuff that you're teaching us.
Yeah.
So.
Yeah, no, it's really cool if for no other reason somebody finds an interest in high school and something and then decides to go off to college and major in that or
Yep.
gonna
Yep.
take that path, right? Like I had no idea. I just knew that I was gonna be a computer science major. That's like what my dad did. So
Yeah.
it ended
Yep.
up being all right, but
Yep.
being or gives you a little bit of head start at life, I think. Going
Mm-hmm.
into it with knowing what your passion is.
Yeah.
So,
Yeah.
Yep.
discovered it, but it took a little while. I think that's pretty
Cool. Well, I
All
gotta
right.
go fix our printer for my husband. He's downstairs, and I don't like him messing with the cartridges. So I'm gonna go swap out the yellow cartridge in the laser printer.
Deal.
All right. We'll
Good
see you
class tonight.
Wednesday.
Got one more on Wednesday.
Yep.
Awesome.
All right. Thanks, guys.
Thank you. See you later.
Ronnie.
Bye.
See you,
Good night.
Maple.
Yep. See
Night.
you, Jeremy. See you, Ronnie.
Bye.
There we go. All right, this concludes tonight's class on storing and managing data in the enterprise. This is class 7 of the data manipulation and management within Omaha Data Science Academy. Join us on for the final class next, which will be advanced database functions. This will include things like temporary tables, proceed this in the SQL procedural language, which is a bit different than the query language, and has a little bit of different purpose. It's more of a transactional language that'll help us create things like stored procedures, database triggers, and user-defined functions. Until then, I'm Jeremy Bergman, and I will see you next time. Bye.